Right, I'd like to thank the organisers for asking me to come and talk to you today about new improved validation and deposition tasks that we've just put into CCP4i2 and will be released with CCP4 7.1. So CCP4i2 has always had a deposition task, dedicated deposition task. The old one dates back, which was called prepare files for deposition, dates back to the days when PDB extract was used to turn the PDB files that came out of refinement into MMSIF format for deposition in the PDB. But as hopefully everybody here knows, from the beginning of July, the PDB decided that it was mandatory that that coordinates from crystallography were deposited in PDBX MMSIF format. And so from the end of June, our CCP4i2 deposition task was modified so that the PDBX MMSIF files written by REFMAC would be used directly. As Philly said, CCP4 7.1 is going to bring GEMI, which has provided us the opportunity to completely overhaul the deposition task in CCP4i2. And the aims we're working with were firstly to reduce the amount of information that you have to manually type into the OneDep website when you deposit your structures, because people are publishing papers with more and more structures at once these days, and so typing this sort of stuff in is pretty frustrating. And a lot of this information is stored in the database in CCP4i2, so if we can add that automatically to the file before we deposit it, that will save a lot of time, and also should improve the quality of the statistics that are deposited with the structure, and also to validate files before deposition. And so before I go on to that, this is not new in 7.1, but a brief sort of aside. CCP4 distributes more probity, and Jon Geer wrote a interface for more probity in CCP4i2. And this is run automatically now, by default, after every refinement run in REFMAC. And this produces a nice report with the summary of the mole probity statistics and some more detailed information on outliers. And also, it writes a script that gets automatically added to a Qt task when you click the follow from button at the end of the report. So that will get loaded into Qt, and then you can sit and click through the outliers and correct them, inspect them, save the updated structure, and carry on. So if you're continuously looking at the mole probity reports as you're building and refining your structure, hopefully just before deposition there'll be fewer issues to fix. So what has changed between the old prepare files for deposition task and the new, imaginatively named, prepare and validate files for deposition task? So this new task was written by Martin Noble in Newcastle. Underneath, it uses John Beresford's adding stats to MMSIF and wwPDB validation code, which communicates with the wwPDB validation server via a Python API, so it both deals with sending the coordinates and data off and getting the validation reports and validation statistics back so they can be presented in CCP4i2. But the main difference that will be immediately obvious for users between the old and new task is that there is much less clicking. And this is because this task is able to interrogate the IT database and discover all of the files that were associated with the refinement run that produced the coordinates that you'd like to deposit and fill in lots of boxes for you. Now that means that there's this new part of a I2 widget which is this widget here, which has no browse files button. It's gone. And as an aside, from experience of using I2 quite a lot, and also demonstrating I2 and running a couple of summer schools where we used CCP4i2 extensively, I think that the CCP4i2 user experience is much better if you use the dedicated import tasks to get data coordinates into CCP4i2. And from then on, you should really only need to be selecting things from these drop-down boxes. And that sort of seems to make the workflow much more streamlined, particularly if you click the sort of follow from buttons at the bottom of one task to move to the next task and everything gets filled in automatically. It really does make life a lot easier. Certainly, you should, if you're using this button to browse through the CCP4 directory structure to pick up files called things like xyzout.pdb, you're definitely doing something wrong. We'd appreciate bug reports telling you saying why you have to do that. But because of this, there is one new thing to note about this new deposition task. The coordinates have to come from the output from a refinement run with REFMAC run in CCP4i2. And depending exactly on the release schedule, this will probably mean that it has to come from the output of a REFMAC task run in CCP4i2 in CCP4 7.1. So you may need to rerun the final step of refinement in 7.1. Sorry about that, but we rewrote bits of the database to deal with this. So here's a quick demonstration of how it works. You have to choose a sequence file that describes an asymmetric unit contents file, which describes the contents of the asymmetric unit, surprisingly enough, and the output from refinement. And then all of these boxes are filled in automatically. The database interrogated, the files from previous runs that go into this run are identified. We know whether you used anomalous data in the REFMAC job, whether you said that the crystal was twinned and used intensities, and all of that is picked up. It then also finds the data reduction task that produced data reduction statistics and picks up XML from that, so that those statistics can be added to your coordinates. So sometimes, though, that's not always possible. And so in this example here, what's happened is data were reduced in space group P3121. Structure was solved by molecular replacements, and phase are identified that the correct space group was P3221. What happens in this case is that CCP4i2 runs a job to change the space group to the new space group and has the original data written out in that space group, and clicking the follow from button at the bottom will automatically load that data into a subsequent REFMAC task. So the user never needs to worry about changing the space group, but the original data reduction task and the reflections that went into refinement are in different space groups. And so that breaks the link in this automatic detection. And then what happens is that the interface detects that and tells you that it can't find the original data reduction job. There's a nice helpful message that tells you what you need to do, and that's as simple as going there and finding it. Or if you decide that you don't want to locate this, you can just unselect that and then uncheck this box. And then everything will run, but your data reduction statistics won't be added to the coordinates, and you'll have to type more things into the OneDep web page. So what does this task actually do. So it adds the sequence information from your asymmetric unit contents file. And if you've chosen to, it adds the data reduction statistics to the PDBX MMSIF file. It prepares the reflection data in MMSIF format and sends those two files off to the OneDep validation service and returns you the validation reports. So, if it goes. The running report could probably do with a little bit more information than this, but mainly the vast majority of this time is just waiting for the validation service. So I've sped this up quite a lot, so we don't have to stand waiting for a few minutes. And then the report shows you the familiar validation sliders, some summary validation statistics. So we can now look at what this task has produced. What's the output data? So we have a coordinates in PDBX MMSIF formats. These are straight out of REFMAC. And then what's been added on are the data reduction statistics and the primary sequence. We've also got, we can then export that, save that where we like, or whatever name we like, and that's ready for upload to the PDB. We also have the reflection data in MMSIF format. So in this case, we use anomalous data in REFMAC, and this task will automatically go and find the original intensities and the structure factor amplitudes used in refinement. So both of those get deposited at once. Again, you can save that somewhere. And also, we have the PDF of the validation report produced by the validation server. You can save that or look at that. This is exactly the same report you get as if you run the validation server on the website. But perhaps rather than reading through a text file and looking, more usefully, the validation statistics are written in into a script that can be loaded into Qt. And so this, so when you click on this button here, you can load that script into Qt and look through the outliers. And as you see, these are exactly or very similar to the report from Mole Probity earlier. You see the sliders again. You can click through, fix things, and sort everything out before you deposit your structure. So all of what I've shown you is in 7.1 and will be released in CCP4 7.1. And in the future, plan to add some enhancements and more functionality. So at the moment, the data reduction statistics can only be harvested from running the data reduction pipeline in CCP4i2. In the future, we would like to be able to add data reduction statistics from when you've run ZIA2. This is particularly important, as David mentioned, that now ZIA2 will run dials, symmetry, dials scale, and dials merge to reduce your data, and so we need to get the data reduction statistics from that and be able to add that to the coordinates before you deposit them. We also want to generate table 1 templates for you to add to the paper describing the structure. Carl Stevenson has written some code that produces table 1 in both docx and LaTeX formats, so you can add those to your manuscript. We just need now to make sure that those statistics are exactly matched those that are added to the file before it's deposited, so that your data reduction statistics in your publication match those on the PDB, which is quite often not the case. And so that finally, all it needs to do is acknowledge some people. So Martin Noble wrote a lot of code, and so did John Beresford. I'm employed part-time in Newcastle and funded by CCP4 for that. And all that remains to say is this will be available in CCP4 7.1, and whenever that's released, you'll be able to take advantage of it and use it. Thank you very much.